Welcome to the deep dive. We know there's just so much information out there, it's overwhelming, right? Especially when it comes to health and fitness. Our job here is to cut through all that noise, sift through the research, and give you the key insights you actually need, your shortcut to being well-informed. Today, we're diving into, well, a really fascinating piece of science. We're asking if maybe land-based exercise is tough on your joints, can just spending time in the water actually make a difference? And more specifically, how do different types of water exercise affect things like your vascular health, your heart rate, maybe even your muscle mass? And, what's the most efficient way?
Yeah, that's exactly the question the pretty impressive study aimed to answer. Our main source today is titled, Aquatic High-Intensity Interval Training Improves Vascular Function, whereas aquatic moderate-intensity continuous training lowers resting heart rate in overweight and obese young adults. A randomized controlled trial. Quite a mouthful, but it tells you a lot. It's by Zhendong and a whole team of researchers from places like Guangzhou Sport University, Universidad Politécnica de Madrid, Jinan University, the Chinese University of Hong Kong, and Macau University of Science and Technology. It's published in the Journal of Sports Science and Medicine, the 2025 volume. We'll link the DOI in the show notes, of course.
Okay, great. So our mission for you today is to unpack this. We want to look at the specific, maybe even surprising benefits of these two different kinds of water workouts. The goal is to help you understand, which one might actually be better, depending on what you're trying to achieve for your health. Targeted knowledge from solid science. So let's set the stage first. Why is this research even necessary? Well, we're facing a, frankly, huge global health issue. Think about this. In 2022, over 1 billion people were living with obesity. That's staggering. It's more than doubled since 1990. But here's the bit that really gets me. It's quadrupled among adolescents. This isn't just something affecting older adults anymore. We're seeing it much younger. And that puts young people at a way higher risk for chronic stuff later on, hypertension, diabetes, cardiovascular disease. It really highlights the need for effective prevention, especially in young adults.
Absolutely.
Yeah.
And a key part of this problem is the link between obesity and something called vascular dysfunction. Basically, that just means your blood vessels aren't working optimally. You might hear terms like endothelial dysfunction, that's the inner lining of the vessels not relaxing properly, or arterial stiffness, where the arteries lose flexibility. These aren't minor things. They're actually early steps towards atherosclerosis, hardening of the arteries, which of course is a major risk for heart attacks and strokes. So tackling this vascular dysfunction early on is, well, critical.
Right. And we all know land-based exercise is generally recommended, good for health. But let's be real, for someone carrying extra weight, it can be tough. High-impact stuff, high-intensity training, the stress on the joints, especially knees and hips, can be significant. The risk of injury goes up. That can make it really hard for people to actually stick with an exercise program, can it?
Exactly. Which leads to the question, what are the alternatives? And this is where aquatic exercise really comes into its own. It's a very promising option. Why? Well, the obvious reason is buoyancy. The water supports your body, takes the weight off your joints, and drastically cuts down that injury risk. But it's more than just that. Being immersed in water actually has direct physiological benefits. The hydrostatic pressure that gentle squeeze from the water helps push blood back towards your heart. It improves venous return, increases the volume of blood the heart has to pump. It sort of gives your cardiovascular system a helping hand. It's a supportive, yet powerful environment.
Okay, so water is great, less impact, plus these extra benefits. So the researchers basically asked, okay, given that, if we compared different types of exercise in the water, what happens? Like, how do they stack up against each other for improving vascular health and aerobic fitness, specifically in these younger adults who are overweight or obese? That was the knowledge gap they wanted to fill. All right, let's get into the nitty-gritty. How did they actually do this study? What did the experiment look like?
Well, they used a really robust method, a randomized controlled trial, often seen as the gold standard, They recruited 61 young adults, age 18 to 45, who were overweight or obese, defined as a BMI of 25 or higher. And importantly, these were people who knew how to swim, they were skilled swimmers, but they weren't currently active. They hadn't exercised regularly for at least the last 3 months. 56 participants actually completed the whole 8-week study.
Okay, skilled but inactive. Makes sense. So what happened to these 56 people?
They were randomly split into 3 groups. Random assignment is key here to make sure the groups are comparable at the start. One group did aquatic high-intensity interval training, we'll call that AHIT. Another did aquatic moderate-intensity continuous training, or AMICT. And the third group was a control group who just carried on with their normal lives.
Okay, AHIIT, AMICT, and control. Got it. So what did the exercise actually involve for the HIIT and MICT groups?
All right, let's break that down. The HIIT group did bursts of intense activity, specifically 12 sprints of breaststroke, each lasting 30 seconds. These were hard sprints, aiming for 85–95% of their maximum heart rate. Then, they got a 60-second rest between each sprint. So if you add it up, the actual intense swimming time was only 6 minutes per session. The whole session, with warm-up and cool-down, was about 18 to 20 minutes.
Wow, only 6 minutes of actual hard work. That's surprisingly short.
It is. Now compare that to the MICT group. They swam breaststroke continuously for 30 minutes without stopping. But their intensity was lower, kept moderate around 70–75% of their maximum heart rate. Both exercise groups did their sessions 3 times a week, Monday, Wednesday, Friday, for 8 weeks. And the pool temperature was kept at 25 degrees Celsius. The control group, meanwhile, just did their usual thing.
Okay, so short, sharp bursts versus a longer, steadier swim. And how did they measure if it worked? What were they looking for?
They measured quite a few things very carefully. First, body composition, things like weight, BMI, body fat percentage, and also skeletal muscle mass. They used a bioelectrical impedance analyzer for that.
Okay, standard stuff.
Then aerobic fitness. They measured VO2 max, which is basically a measure of how efficiently your body uses oxygen during exercise. That was done with a cardiopulmonary test on a stationary bike.
Right, the VO2 max test always sounds tough.
It can be. But the really interesting part, I think, was how they assessed vascular function. They used several advanced techniques. There was the ankle brachial index, or ABI, which gives an idea of arterial stiffness in the legs. Then pulse wave velocity, PWV, for a more general measure of arterial stiffness. And crucially, flow-mediated dilation, or FMD, of the brachial artery in the arm. FMD tells you how well your blood vessels can relax and widen when blood flow increases. It's a really key indicator of endothelial function, that lining we talked about.
FMD, okay, that sounds important for vessel health. Anything else?
Yes, they also measured resting heart rate. Simple, but informative.
And they were pretty strict about the measurements, right, to make sure they were accurate.
Oh, definitely. Participants had to follow specific protocols before testing. They had to fast, avoid caffeine and alcohol for 24 hours, and make sure they got at least 7 hours of sleep the night before. This kind of control really helps minimize other factors influencing the results, so you can be more confident that any changes you see are actually due to the exercise. It adds a lot of scientific rigor.
Okay, fantastic. Rigorous design, careful measurements. So, drum roll, please. What did they find? This is where it gets really interesting, right?
Exactly. Let's start with what both exercise groups achieved, the common ground. Both the AHIT and the MICT interventions led to significant positive changes in body composition. So participants in both groups saw their BMI go down and their body fat percentage decrease.
Okay, so either type of swimming workout helped with weight and fat loss. That's good news.
Definitely. And crucially, both types of exercise also significantly boosted participants' VO2 max. So both are effective for improving overall aerobic fitness. No surprise there, perhaps, but good confirmation.
Right, so both help you get fitter, both help with body composition, but you mentioned earlier that maybe they affect the vascular system differently. Did they see differences there?
Ah, yes. This is where the results really start to diverge, and it's quite revealing. Let's look at AHII first, the high-intensity intervals. Only the AHII group showed a significant decrease in that ankle brachial index, the ABI. A lower ABI generally suggests better blood flow and less stiffness in the leg arteries.
Okay, so HIIT was better for leg artery tone. What about that FMD measurement, the vessel flexibility one?
That's perhaps the most striking difference. Only AHII significantly increased flow-mediated dilation, the FMD. They also saw an increase in the peak diameter the brachial artery reached. Remember, FMD reflects how well your blood vessels can relax and widen. Improving FMD is a really strong sign of better endothelial function, which is fundamental for cardiovascular health.
Wow, so the short bursts specifically improved that key measure of blood vessel health. Anything else unique to HIIT?
Yes, one more thing. The HII group was also the only group that showed a significant increase in skeletal muscle mass.
Interesting. Gaining muscle from swimming sprints.
It seems so.
Hmm.
And what's really intriguing is how these things might be connected. The researchers found correlations. For instance, bigger improvements in VO2 max were linked to bigger improvements in FMD, fitness, and vascular health going hand in hand.
Makes sense.
But here's a fascinating specific link for HIIT. Changes in body weight were positively correlated with FMD improvements only in the HII group. And this link was even stronger for those participants who also gained muscle mass.
Huh. So losing weight and gaining muscle with HII somehow related even more strongly to better vessel function. Why would that be?
Well, the researchers speculate a bit here. It could be related to something called laminar shear stress. That's the force of blood flowing smoothly along the vessel walls. High-intensity exercise creates higher shear stress, which can stimulate the endothelium to produce beneficial substances. Or, and this is a really exciting area of research, it could involve myokines. These are substances released by contracting muscles. Think of them like messages your muscles send out. Maybe the intense contractions during HIIT trigger the release of specific myokines, like irisin perhaps, that travel through the blood and actively improve blood vessel function, like your muscles are sending out little repair signals.
Wow, muscles talking to blood vessels. That's cool. Okay, so AA seems great for vessel function and maybe muscle gain. What about the other group, the moderate continuous swimming, AMICT? Did it have any unique benefits?
It did indeed have one specific vascular advantage. While AKIT didn't significantly change resting heart rate, NICT did. Only the moderate intensity group showed a significant lowering of resting heart rate.
Oh, okay, so MICT is better for bringing the resting heart rate down. Why would that be?
It likely ties back to that effect of water immersion we mentioned. The hydrostatic pressure helps return blood to the chest, which activates the parasympathetic nervous system, the rest and digest system. This promotes a lower heart rate, creating what's called vagal dominance. With moderate intensity exercise like AMICT, this effect seems to persist. But with high-intensity exercise like AHIT, the fight-or-flight sympathetic system gets activated strongly, which likely counteracts that water immersion effect on heart rate during the exercise itself. So, AMICT lets that calming effect on heart rate shine through more.
That makes sense. Different intensities, different nervous system responses, and you mentioned some things didn't change much.
Right. It's also important to note what didn't show significant changes in either group. Things like overall arterial stiffness measured by pulse wave velocity, or PWV, and also systolic and diastolic blood pressure.
Why not? You'd think exercise would improve those too.
The researchers suggest it's likely because these participants were young adults who, despite being overweight or obese, probably started with relatively healthy blood pressure and arterial stiffness levels. So there wasn't much room for improvement on those specific measures in this group. Doesn't mean the exercise wasn't beneficial, just that these particular markers didn't shift significantly from their already decent baseline.
Got it. So let's boil this down. What's the big takeaway for someone listening? What's the so what here? You mentioned time efficiency earlier.
Yes, this, I think, is one of the most practical and honestly startling findings. The AHI group achieved those specific vascular benefits, the improved FMD, the better leg artery tone, the muscle gain with a remarkably small amount of actual exercise time. Over the entire 8-week study, the total effective exercise time for the AHII group was just 2.4 hours. That's the total time spent actually sprinting over 2 months.
2.4 hours, seriously,
Compared to the AMCT group, which accumulated 12 hours of effective swimming time over the same period to get their benefits.
Wow, so a five-fold difference in the actual time spent working hard. That's huge.
It's a massive difference. It suggests that if improving certain aspects of vascular function is your goal, AHIIT in the water is incredibly time efficient. You're getting significant bang for your buck, time-wise.
Okay, so let's summarize the main conclusion then. It sounds like both types of aquatic exercise, the short, intense bursts or the longer, moderate swim, are great for improving general fitness, VO2 max, and body composition in young adults who are overweight or obese.
Absolutely. Both are effective tools in the toolbox.
But they seem to offer different specialities, right? If your main goal is really honing in on vascular function, improving that endothelial flexibility, maybe gaining a bit of muscle, then AHI looks like a super time-efficient way to go.
Precisely. Highly targeted benefit from minimal time investment.
Whereas if a key objective for you is to lower your resting heart rate, then the moderate continuous swimming AMICT seems to be the better choice.
That's what these findings suggest, yes. Different tools for different jobs, essentially.
Now, we should probably mention, are there any caveats? Any limitations to the study we should keep in mind?
Of course, like any single study, the researchers themselves point out a couple of things. The sample size, 56 completers, is relatively small. So generalizing these findings to everyone needs a bit of caution. Larger studies would be needed to confirm this more broadly. Also, they didn't monitor the participants' day-to-day diet or overall lifestyle outside the exercise sessions in great detail. So, while unlikely to explain the differences between the groups, it's a factor to consider.
Okay, so standard limitations for this type of research, but still, the findings seem pretty compelling, especially that time efficiency point for HIIT.
Definitely significant findings, despite the limitations.
So for you listening, this deep dive really shows that choosing the right type of aquatic exercise could be a really smart, targeted, and potentially very time-saving strategy, especially if you're younger and looking to manage obesity-related health risks. It's not just about moving, but moving in the way that best suits your specific goals.
Yeah, and it opens up some really interesting thoughts for the future, doesn't it? Imagine if these results hold up in bigger, more diverse studies. Think about public health. Could we design really accessible, targeted aquatic programs, maybe short HIT sessions for vascular health, or moderate sessions for heart rate that could genuinely make a dent in the obesity and cardiovascular disease trends, especially for young people? And that whole idea of myokines, those muscle-derived factors, what exactly are they doing? Could understanding them better lead to even more effective interventions? There's still so much potential there.
Fascinating stuff to think about. If you're intrigued and want to dig deeper into the science yourself, we absolutely encourage you to check out the full study. Again, the title is Aquatic High-Intensity Interval Training Improves Vascular Function, whereas aquatic moderate-intensity continuous training lowers resting heart rate in overweight and obese young adults. It's by Zhendong Yu and colleagues in the 2025 Journal of Sports Science and Medicine. Check the show notes for that DOI link. And if you found this deep dive valuable, please do follow our channel, turn on those notifications. That way you won't miss our next exploration into the world of knowledge. Thanks so much for joining us on the Deep Dive.